recording. Oh, I see that Craig is here, Adam is here. Yeah, we can slowly start. So welcome to our meetup. Today we're gonna have a session with Magnus Hagander about Postgres 13, and just want to announce Magnus a bit, because actually Magnus is the reason why this meetup exists, because like he talked me into that a couple years ago in Warsaw. So thank you for that, Magnus. You are kind of like founding father of this meetup. And he is, of course, Postgres Core Team member and committer, so really huge person in the community. And what you can know about Magnus, that you can blame him like for a lot of stuff, because the blame Magnus hashtag is quite popular now, so you can blame Magnus whenever like something in Postgres or like in other stuff doesn't work for you. So Magnus, the stage is yours. Thank you for giving this session.
Okay, thank you very much. And thank you for that introduction. And yes, I'm glad my work to convince you to start a user group in Warsaw worked out. Sadly, the first time I get to actually speak at it, then I don't get to go there and have to do this virtually and remote. But I'm looking forward to some point later to actually visit the user group and
after the
or just join.
Yeah, I would love to have you here in Warsaw.
So I'll definitely look forward to that. But for now, under the current circumstances, it's obvious to do the whole thing virtual. Luckily, we are open source people. We're used to working across the internet and things like that. We were probably the ones who were the best prepared for this sudden, oh, we all have to work from home now. Where it turns out a lot of us already did work from home. And if we didn't, a lot of the things that we did, we were already used to communicating over internet, just usually through email. And now there's more video. But other than that, it's all basically the same. So let's talk a little bit about Postgres, talk about Postgres 13 and what's happening in this one. First of all, a few words about myself. Well, Alicia already introduced me as on the Postgres side. I'm a member of the core team, one of the committers. I'm serving on the board of Postgres Europe, which is the advocacy coordinator nonprofit for Europe, where we run the big conferences like Postgres Conference Europe, those FOSDEM, etc. And we support user groups like the one in Warsaw. For my day job, I work for a company called Red Bull Linpro. We're an open source services company that's based in Scandinavia. We're big in Sweden and Norway, have a little bit in Denmark. And I'm based out of Stockholm in Sweden myself, where I head up our sort of database offering within our infrastructure and general DevOps style department. Company in general works with all sorts of open source, but support, services, training, things like that. Well, enough about me. Let's talk about Postgres. Let's talk about Postgres 13. And yes, it should be clear by now. This is one of the questions that I fielded a lot of times in the first times that I gave this talk is there really going to be a Postgres 13? Aren't you guys just going to skip it and move to Postgres 14? And the answer is yes, there is going to be a Postgres 13. And the fact is that Postgres 13 is almost done. It's not done yet, but we're getting very close. If we look at the development schedule for Postgres 13, it actually started just about a year ago in July of 2019 when we branched Postgres 12. Now, the way that development works in Postgres is that we do all new feature development on what is known as the head branch or the master branch in Git. And then at some point we say, okay, we're done now. So in July 2019, we created a branch in Git called release 12 stable. And by doing that, version 12 is now magically stable and we're done. Well, I mean, maybe not quite that easy, but the idea is at that point, we have this stable branch for version 12, which will now contain only the bug fixes that will first go into version 12 and then into all the minor release bug fixes for it. And at that point, the main master branch opens up for development of what will turn into Postgres 13. At this point, we also started our first, in July 2019, we started our first commit fest, as we call them. That's just the Postgres terminology for how we do iterative development, where the idea is we spend 1 month approximately building features, and then we spend 1 month reviewing and getting these features committed to the master branch or merged or whichever terminology you prefer to use. These are what we call the commit fest. So we ran the first one in July, ran a second one in September, we ran one in November, and I realized now that should be November 2019. We did not time travel. One in January and one in March. And our current state is that in June 2020, actually last week, we released the second beta version of Postgres 13. And our target is and remains a release in the September to October timeframe. That's what we've been targeting over the past couple of years, and it's been working reasonably well. Of course, we all know this is an IT project and how good we are at finishing on time and things like that. But that is the target. But right now, you can get the beta 2 version, and hopefully we'll be looking at a release shortly after summer. So let's look into some of the things that we actually have in Postgres 13. Now, some of you may have seen me do this type of talk before. I do this basically for every Postgres version, where I try to slice up all the bunch of features that we have into 4 different categories. I choose DBA administration, SQL and developer, backup and replication, and performance. And that's mainly just to separate them out and get little subsections in the talk. In turn, like there's very little like DBA administration, SQL developer, that's all very similar today. So I've just decided to split it out where primarily what I put under administration is things that is not done through SQL, and developer are things that are done through SQL, but the difference is really not particularly important. Then, of course, we have backup and replication, and everybody loves performance, right? So I'll go through these features, sort of a teaser version of each one of them, and you can get more details in the online documentation and things like that. But before I get that also, we have some smaller features that are really useful. I'm sure you've all used the command drop database at some point. And you probably run into these issues where like you run something like this, you run drop database production, right? And then it just hangs. And the reason it hangs is because there are users connected to the production database, like maybe our application server running our production website or something like that. Now, Postgres 13 lets you solve this problem. You can now just say drop database production with force, and that will actually drop the database even though there are users connected to it. And now you get to do what you wanted, and then you get to test your backups. The only thing that with force will not work is you cannot drop the database that you yourself are connected to. But any other users in this production database will get disconnected, and then the database is gone. So excellent way to get to check out your resume and look for a new job. There are some breaking changes in Postgres 13. They're not as bad as we've had in some versions, like Postgres 10 killed almost every script people had by renaming xlog to val, and Postgres, I think it was 9.2 that changed the columns in pgstat activity. But there are a couple of things to consider. One big thing is that many of the wait events that Postgres are using have been renamed. These are the ones that show up in pgstat activity as wait event type, and they've been renamed to be more consistent. They were completely inconsistent before, and it's one of those, well, we have to pay the price at some point, and might as well do it now. But that means that if you have monitoring somewhere that is polling for particular wait events, it will have to be updated. And if you have monitoring that's collecting all your wait events, you will have to be ready for the fact that the wait events that are being collected will have their names changed in this version. So sort of over time analysis can get wrong across that. Another change is that the timing columns, if you are using pgstat statements. Now, first of all, if you are not using pgstat statements, you really should look into using pgstat statements. It's an excellent add-on that gives you brilliant insight into how your application is doing. And pgstat statement is not new. It's been around for a long time, and it's been useful for a long time on Postgres. So that's something you should consider installing already in your existing Postgres if you haven't done that already. It's in the contrib packages, so you have to add it to shared preload libraries, and then you just have to do a create extension pgstat statements. Now, pgstat statements has 5 timing columns in current versions. There's total time, minimum time, maximum time, mean time, and standard deviation time. These 5 columns have been renamed in Postgres 13. They're now total exec time, minimum exec time, maximum exec time, and mean exec time, and standard deviation exec time. So basically, it's added the word exec in the middle. The reason for that is that there are new measuring values that are coming in here into pgstat statements that I'll go into a bit later, which would otherwise sort of conflict with these names. And I think at this point, it can be argued whether these should have just been left over, but then it would have been inconsistent. Instead, the choice was made to rename them, which breaks backwards compatibility at this point. It's a simple break. It's easy to fix, but it does break it. But instead, it becomes consistent into the future. So this is sort of paying the cost up ahead rather than waiting for later and paying a higher cost. At least that's the argument behind how this part is done. So let's look at the actual cool new features that are coming in Postgres 13, because there's quite a few of them. And let's start a look under DBA and administration. If you are using custom statistics, these extended statistics is the correct term that we've had in Postgres for a while now, where you can say create statistics in order to collect statistics on combinations of columns, right? By default, Postgres will only collect statistics on individual columns, and then you can create a named set of statistics saying, I want to look at these 2 columns in combination, right? Where, is there functional dependency and things between them. And the new thing in Postgres 13 is that you're now able to change the statistics target for the extended statistics with the wonderful command alter statistics set statistics. Say that fast 5 times in a row. Right? The idea is previously it would get the statistics target by looking at the underlying columns, but now you can have a different statistics target for the underlying columns versus the combination of columns that is in our named set of extended statistics. So this gives our extended statistics yet another way to help improve our query plans. In progressing along, we've had a bunch of different pgstat progress views for different things like vacuum and create table. Postgres 13 now adds a view for pgstat progress analyze. Tells us how far along we are in the analyze, tells us how much data has been generated, similar to the other pgstat progress views. So we can see how things are happening. Just like the other views, if you have a running analyze, in order to see how far it's been running, you have to create a new connection and query this view from the other connection, and it will then be able to tell you how far along your analyze is, or your auto analyze that's running in the background, how far along it has been going. The reindexdb command now has a parameter to run parallel. So you can say, -J4 to run 4 indexes in parallel. Now, it only goes parallel if you are reindexing multiple indexes, right? If you're only reindexing a single index, that will still just run in a single connection, thereby running across a single CPU. But if you run it with -J, you can just scale it out across multiple CPUs. One thing to remember here is maintenance workmem will be used once for each. So if you do a 10-way parallel reindexdb, it will use 10 times as much memory. So you want to be careful if you're putting those numbers up. But one of the initial sort of big reasons for building this feature is, for example, if you've upgraded your operating system, and if you haven't noticed that, there's been a change in glibc that changes sort order for almost every language. And if you upgrade your operating system independent of when you upgrade Postgres, past this breaking point, and I believe that breaking point is, for example, it's in Debian 10 Buster, it's in Red Hat 8, suddenly your indexes are incorrect. And then you need to reindex all of them, and that's a good use case to run a parallel reindexdb. Normally, like on the production system, you probably pretty much never want to do this because you might need to reindex, but you'll be reindexing individual indexes, and the parallel one doesn't really make that much of a difference. Another thing that's now available to go parallel is parallel vacuum, which is partially parallel, which is if you vacuum a table, but you say vacuum parallel my table, the main vacuum of the table is still serial in a single connection across a single CPU. But as it proceeds to vacuum the indexes of the table, it will parallelize out the index vacuum operations, which again, for tables with multiple indexes, which is a lot of our tables that do have more than one index, this can make your vacuum run significantly faster by taking advantage of the fact that you probably have more than one CPU core in your databases today. Most people do have that today. Proceeding on the topic of vacuum, auto vacuum, which I'm sure you're all aware of at this point, can now be triggered by insert. Okay, in Postgres 12 and earlier, the vacuum part of auto vacuum would be triggered by updates and deletes, or it would be triggered by table age, where it would launch one of these freeze vacuums or anti-wraparound vacuums. The problem with that is that if you have basically a table that is insert only or very close to being insert only, vacuum just wouldn't run on the table. And then once it hit this wraparound threshold, it would run on the table, and now it would have to run across the whole table and mark every row in the entire table as visible, which would take time and be a very expensive operation. There's another reason as well for wanting to run vacuum more frequent on an insert-only table, and that is that until vacuum has run, you will not be able to utilize index-only scans on this table. Because when vacuum runs and it freezes or the tables, when it marks a page in the table as everything on this page is now visible in the visibility map, and that's something that vacuum does, that's when it can start being used for index-only scans. So if you have an insert-only workload, it would take hundreds of millions of transactions, basically the wraparound limit or wraparound trigger, until you could do index-only scans. The idea behind this now is to run vacuum more frequently on this type of tables, where each individual run will be cheaper because it will have less work to do, and thereby keeping things up. Two new configuration parameters for this one: auto vacuum vacuum insert scale factor and auto vacuum vacuum insert threshold, which work exactly the same way as the previous ones for regular vacuums and for auto analyze. The vacuum that runs is exactly the same as any other vacuum. This only changes when this vacuum is triggered to run. There are new parameters for something we call slow query sampling. The idea here is you may want to set a slow query log using something like a log mean duration statement. But the problem is then, if you set it too high, you miss your queries. If you set it too low, you end up... where did my window go? If you set it too low, you end up overloading your system with logging because you're just throwing out so much log data. You can use this instead of log mean duration statement, or you can use it together with log mean duration statement. So an example here is we say log mean duration sample equals 100 milliseconds. Log statement sample rate equals 0.1. That means that for every query that takes more than 100 milliseconds, log every 10% of them, 0.1, right? So every 10th of those queries gets logged. That means we're lowering the amount of log data. Setting log statement sample rate to 1 would make a log mean duration sample the same as log mean duration statement. You can also still set log mean duration statement. So a classic for that would be, you might set log mean duration statement to 30 seconds and log mean duration sample to 100 milliseconds. Then it will log 10% of the queries that are 100 milliseconds or slower, and all of them that are 30 seconds or slower. So they work. If you set log mean duration statement to a value equal to or lower than log mean duration sample, then you just log everything. So then that's just silly. So I see a question showed up in the chat. That's how I lost my window, which is, does AccuVac, can AccuVac auto vacuum now may improve performance for PG bulk load or copy, or just for bulk inserts? Yeah, it will help you for copy. It doesn't help you with the copy itself, but as the vacuum runs after that, it will enable that table for use in index-only scans. Now, if you are loading a table sort of without having transactional requirements, you can also look at copy freeze, which basically loads pre-vacuumed data, if you will. If that works for you, that can be an excellent performance enhancement on it. However, you should be aware that there are transactional issues that can, like some weird things can happen if you use that one. But if you are bulk loading data, it can certainly be worth looking at it. There's a whole bunch of things that have changed around SSL. Now, of course, as you hopefully know, Postgres call all the configuration parameters, all things around that are called SSL, but Postgres doesn't actually support SSL. It only supports TLS, and it supports a bunch of different versions of TLS. And the changes that we've done here is Postgres 13 will drop support for OpenSSL version 1.0.0 and lower, meaning that the new minimum version of OpenSSL is 1.0.1. Now, 1.0.1 is pretty old, so it's should not be a problem. There are some other changes. The new default minimum SSL version in Postgres is TLS version 1.2. That's what is generally considered the lowest version of TLS that's acceptable by people that know security. You can change this in the configuration if you have clients that are so old that they can't speak TLS version 1.2, for example. You can go into the configuration file and change it back down to TLS version 1.0 if you want, but you shouldn't unless you have to. Or you can increase it to TLS version 1.3, in which case, of course, you will get breakage with any client that doesn't speak that. You can now also control the SSL version in the libpq connection string by saying SSL min protocol version and max protocol version. You could configure these on the server side in 12. It's just that we've changed the default. There are discussions, and I just sort of lost my train of thought for a moment trying to remember. There are discussions of also changing the libpq default minimum to TLS version 1.2. I don't think it's actually been done yet, but so not in beta 2, but it might still happen for this version. Okay, so that's it. If I suddenly go offline and something happened to my Wi-Fi, because there is just now a major thunderstorm outside. So hopefully I will not lose internet. Usually doesn't happen, but you never know. Okay, so moving on. You now have a parameter. You can set SSL password to provide a password unlock key. This is a libpq parameter. And you can also, using the API, set a hook that calls back to your application to ask for the password to unlock the key. This is if you are using client certificates to connect or to use the system. Channel binding is how you can tie your SCRAM authentication, which hopefully you're all using, right? You're all using SCRAM, right? If you're using username and password, you should be using SCRAM. You just need clients that support it, which is new as of Postgres 10. And channel binding can now be enforced. And without enforcing it, it doesn't make all that much sense. So if you, in your libpq connection string, say channel binding equals require, it will fail to connect to your server if it cannot set up channel binding. And again, channel binding is what ties your password login to your TLS session. Now, for example, it prevents there from being a man-in-the-middle attack. It prevents there from being a proxy. So it will, as far as I know, break PG Bouncer. But if you're not using that, then channel binding can be a way to further enhance the security of your system. The Postgres FDW for a data wrapper has learned how to use SSL key and certificate instead of users to log into remote servers. And it can also use peer and GSS authentication by setting password requires to false. Obviously, this is something that only a super user can do because you will be basically logging in as the server, but it is there and it is available. PGStat-SSL has been changed to now only contain rows for actual connections. Prior versions would include rows for background processes and parallel query and things like that, which obviously would never have SSL. Like your auto vacuum daemon will never use SSL. In the new version, it will now only contain those. That again means that if you have like monitoring views that are sort of joining this to pgstat activity, for example, you may need to change it to be a left join so that you don't lose rows, but it will not remove any actual information. The same change applies to pgstat GSS API, which will now also only show rows for actual connections. There is a new statistics view, pgstat SLRU, which is statistics about what we call SLRU, which is simple LRU structures. These are statistics about your PG exec, PG subtrans, PG multi-exec. There are a number of these system objects where you can now get like cache statistics and things like that about them. They're all in this new view called pgstat SLRU. pgstat activity has gained a new column called leader PID. This is if your the new column leader PID, it will show you the leader in parallel query, right? So if you have a query that's using one master process or one leader process, as we call them, and two auxiliary processes to run across multiple CPUs, then those two processes and the leader will have the leader's PID value in this. So you can figure out which background process is connected with which server. It will be null for anything that is not a parallel query. Okay, let's see. I have another question in the chat, which is, so for Postgres foreign data wrapper with GSS API, it will not do ticket forwarding. It will only use the identity from the server key tab. And yes, that is correct. It does not currently support ticket forwarding. This is very definitely something that many of us would like to see, but no, we do not yet support ticket forwarding this in Postgres FDW or in DB-Link or any of those.
So just to because this is something I am personally very interested into, it is technically possible to implement. There is nothing as of now known that would prevent implementation in the future.
No, I believe that should be definitely doable. I mean, you need to set up Kerberos delegation and all of those things, but there shouldn't be anything that's technically preventing it. It's just a matter of somebody actually getting around to doing it. So that's a bunch of different statistics information. Another thing that is fairly major is we've added support for something that is called trusted extensions. This is basically the ability to install an extension without being a super user. Today, if you want to say, create extension B-tree gist to get gist operators for regular B-trees, you can't do that unless you're a super user. In Postgres 13, you will be able to do that. This will also replace what we had with something called procedural language templates, which basically solved this problem, but just for procedural languages, so that you could say create language PL Python without being a super user. So it replaces this, and it's all folded into the extension infrastructure, where it is up to each extension to set a flag saying, am I safe to install as a non-super user? And there's a bunch of the built-in ones like btrgist, intarray, pgcrypto, and a bunch of, well, I shouldn't say built-in, I should say the ones that ship in contrib that are set to trusted by default. And of course, this is just a flag in the extension control file. So if you build your own extensions, you have the ability to set this trusted flag to true in the extension, thereby letting users make this installation. Of course, if you do that, you have to be really careful to make sure that it is actually safe to do that. Because it basically amounts to all the SQL that's in the extension can run as any user. If that's safe, then you can do it. This includes super users, right? And if it's not, then it should not be set as trusted. as part of this, the support for unpackaged extensions has also been removed. This is basically if you had an extension prior to the fact that Postgres had extensions, there's a command where you could say, upgrade this extension from unpackaged, where it would convert it from sort of the pre-extension days. That support is just gone now. It just means that you have to, if you had any such extensions, you have to first upgrade them on a previous version of Postgres to a version that is packaged as an extension. And after that's done, you can now upgrade it using the regular method. Given that this extension support has been around for a long time by now, I don't think this is going to cause trouble for a lot of people. So let's move on a little bit further into the SQL layer of things on the SQL and developer side. We've extended the generated columns feature, which we've had for a version or two, with the ability to actually get rid of it now. So basically, it just means that if you have a column like this, this is, of course, a really, really stupid column to have, right? Column integer generated always has 2 stored. So for every row, we'll just store the value 2. This is not a great example, but, so it's a stupid enough example that you might want to do something like this. So you can now say alter table, alter column, drop expression, which will then drop the generated expression and turn this back into just a regular column. If you are amongst the many people who use UUIDs, sometimes known as GUIDs, right? The generation of a random UUID is now included in Postgres Core, right? In versions prior to 13, you had to install the UUID OSSP, I think it's called, the extension to get UUID generation functions. The only one that is included is the one that generates a random one. You call it like this. You just say select generate random UUID. You get a UUID back. It's almost magic. The random one is the most common case. Now, if you want the other ways of generating UUIDs, these are well documented. There's like types 1, 2, 3, 4, 5 defined in the UUID standards. They're still all available in this extension. But if you just need to be able to generate random UUIDs, you can now do that without the extension. Of course, one of the main reasons to actually use UUIDs is if you're generating them in the application and not in Postgres, in which case you just need the data type UUID, which has been in core Postgres for a long time. But this is now the ability to also add or generate random UUIDs. If you're using JSONPATH, JSONPATH is the new way of querying JSONB data using the standard JSONPATH syntax, which I find a lot easier or nicer to work with than the previous Postgres syntax as well as just being standard. It now supports the datetime function, which means you can call the datetime function from inside of your JSONPATH queries. Here you can basically say, well, I mean, it's a kind of a convoluted example, but as you can see on the third row, it says $.t, and then it's a .datetime less than, and a string .datetime. That means that it's making the comparison of these two values as a datetime, not as a string. Right? And this also means, I believe, that the Postgres JSONPATH support is now fully spec compliant. It's the first implementation that basically has everything in JSONPATH. At least it was at some point. Okay, let's see. We have another question. So generate random UUID from pgcrypto will be used as the default. No, this is not actually the generate random UUID from pgcrypto. But it's more or less the same. It solves the same problem. So you will no longer need to install pgcrypto in order to get the generate random UUID function. The built-in one will use a strong random number, just like the one in pgcrypto. So you can just stop installing pgcrypto and just use the built-in generate random UUID.
Yeah, but in the documentation is still like to use pgcrypto for that. So it's gonna be like documentation gonna be changed like to recommend the other way.
Oh, we're saying that in the documentation for 13?
Yes, absolutely. There is a note, if you only need random generated version 4 UUIDs, consider using the gen random ID function from the PG crypto module instead. So because, you know, I had like exactly this case like with migration from Oracle. And so, yeah, I actually need that.
I was not actually aware of that, so I will put that on my to-do list of things that I have to look into.
Okay,
and it might be something that we should fix.
I'm just pasting the link to that. There's a note like.
Well, that's from that documentation is Postgres version 12.
Mm-hmm.
Is it changed in version 13?
Yeah, let me see.
Meanwhile, as you're looking that up, we had another question, which is there any performance difference between the built-in and the extension? I would say no. It's basically the same implementation. It should not be a difference.
Okay, there is no node there, yeah, in the 13.
Okay, so the documentation has been updated.
Yeah.
Okay, good.
But it's still, you know, it's still like V4, like in the list. I need to like read that, but there is still like V4, this UUID generate V4. So yeah, I need to read that.
Yeah, I mean, there's still like we still have all the other ways of generating UUIDs, but most people really just want the random ones. Okay, so moving along, Postgres has added support for the fetch first with ties syntax. Now, the way that this looks is it looks something like this, which is of course beautiful because it's just outside of the screen. The important part is the word that you can't see. But if you look at the first row, it's the select star from n, order by I, fetch first 2 rows only. Okay, that's the SQL standard way of what we have traditionally in Postgres just said, select star from n, order by I, limit 2. Right? Give me the first 2 rows. This is the SQL standard syntax. Postgres has had support for this for some time. Right? The difference here is that one will always give you 2 rows. If my table contained, the values 1 and then 2, 2, 3, 3, 3, 4, 4, 4, 4, which is what my table did, it will still show you the 1 and the 2, right? Now, the magic thing that we can do, or well, it's not entirely magic, but let's see if that works. No, let me see if I can scroll this thing. If we instead say select star from n, order by I, fetch first 2 rows with ties, it will give us the first 2 rows, as we see here, and then it will also give us any other row that has the same value in the column that we're ordering by. So in this case, I, right? So we give us all the rows that have 2. So this one, it says fetch first 2 rows, but it'll be at least 2 rows, assuming there are 2 rows in the table, plus however many rows have the same value for the order by column. A regular, the first version, like the top one, the select star from n, order by, fetch first 2 rows only, or limit, does not require an order by clause. You could just say select star from n, limit 2, or first 2 rows only. It becomes kind of a strange result because you're saying, give me 2 rows, I don't care which 2 rows. But you can do that, whereas the with ties one requires that you always include an order by. Otherwise, how would it know which ones have the actual, like the tiebreaker, if you want. So let's look a little bit at backup and replication. What do we have for new cool features around backup and replication? Postgres archive recovery will now fail if the point-in-time target is not reached. What does that mean? Well, it means if you're doing archive recovery, you have your recovery.conf, and well, you don't actually have that anymore. It's in postgres.conf, and when you created your recovery initiation file, and you specify target. Say, I want to restore until July 10th at 5 a.m. Postgres will do the recovery and it'll play back the transaction logs until it reaches this target. If it never reaches this target and it runs out of transaction logs, it will fail and shut down the server. Because this usually happens either because you misconfigured it, maybe you didn't mean July, which is in the future, you actually meant June, in which case you probably don't want the system to open up and start working. Or maybe you have issues with your log archive where it's not finding all the files that it should find. In which case, again, if you explicitly ask for a certain time or a certain transaction or whatever your definition was, and we couldn't find it, previous versions of Postgres would just say, okay, and open up the system and you can start using it, whereas now it will fail. If you don't specify a target, right, if you just say restore everything you can find, then it will work like before. It will restore everything it found, and then it will open up the system, just like before. We have a new view called pgstat progress base backup. How's that for a short and cute view name, right? When you're running a base backup, and this is when you're running a base backup over the replication protocol, so usually using the PG base backup tool, it will show you how far along is this backup. So it's similar to running PG base backup with a progress, like the -p or -- progress parameter. Will show you how many % along it is, how many table spaces, and all that stuff, except you can view it from 8 different sessions. So typically, your PG base backup might be running from a cron job, and you can just connect and see how far along it is. Now, this requires that the progress report has been enabled to show the details, otherwise it won't show them. It'll still show that it's running a backup, just not how far along it is, which means that PG base backup has been changed to turn this on by default. Now, if you have a really large database, it can cost some, like just figuring out how big the database is before you start taking backups can actually be costly. And in that case, you can still turn it off. It's just on by default. And if you turn it off, well, then you lose the ability to use pgstat progress base backup, of course. So let's see, we have another question, which is any plans to parallelize base backup or still only rsync? Well, there is nothing worked on right now. Well, I mean, there's nothing in Postgres 13 for parallel PG base backup. I know there are some people working on it, but it's not there yet. There are external tools. For example, if you use PG backrest, it will do parallel backup, but it does not use the base backup protocol. It runs the lower level APIs, and it will probably be a much better choice than using rsync. There might be other tools out there. I'm not actually sure which of them support parallel backups and which don't. I do know that PG backrest does, because it's the one that I use the most. And when my database is big enough that I need parallel base backup, that's where I go. And if it's a small, simple database, then using PG base backup is a pretty good choice because it's simple, right? But hopefully we will be able to get a parallel PG base backup as well in the future. And there are some things being considered around it. There are some infrastructure being built, but I don't know exactly how far away we can expect that it will be. Another addition to this is that Postgres now has a standard format for backup manifests. And these backup manifests are included when you're taking base backups with PG base backup. Right? And they're basically it's basically a structured file that contains a list of all the things that should be in your backup and a checksum of every file that should be in your backup of exactly what it should look like. And coupled with this, we have a new tool called PG Verify Backup, where the idea is you can say, do PG base backup and store it over here. And then using this manifest that is included in the backup by default, you can say PG Verify Backup, point it to a backup directory and have it actually tell you that this backup is complete and looking good, that you haven't lost a file, that you haven't had data corruption in your backups and things like that. Previously, the assumption, sort of like a lot of parts of Postgres, it just assumed that your storage was doing the right thing. And unfortunately, experience says that it probably doesn't. We've seen really strange corruptions coming from the fact that the backups themselves were corrupt. So this is sort of a version like you still get, if you have checksums enabled on your data directory, which you probably should have, when you run the base backup, it will verify the checksums of the data blocks coming out of the database. And this way you also get a checksum of everything as they're stored in your backup location, whatever that happens to be. Now you can choose a bunch of different checksum algorithms. I think that might be ever so slight over engineering, but it gives people the choice and it future-proofs the tool. But the defaults are going to be fine for pretty much everyone. Along recovery, we also have a new parameter called ignore invalid pages. Don't use this, right? Please. I mean, except when you have to, but don't use this. This is similar to, zero damaged pages or the PG reset while flags that just throws away parts of your data. The idea here is it just ignores error on recovery. If your transaction log contains references to pages that don't exist, we just ignore it. That's not normally something you want to do, because that indicates you have pretty bad data corruption somewhere. You don't want that. But it's another one of those things. Well, yeah, but once you've reached the point and realized, okay, I have bad data corruption, I can't actually restore my database from backup because that's also corrupt, then this might be a tool to use. Just know that this, alongside with those bunch of other things, will actually delete, like it will corrupt your data, but it will make it possible to read your data so that you can recover, whatever is left. But you will not, if you ever turn this on, you will not go back to having everything that you had before. That's not what it's for. On the replication side, logical replication now finally supports replication of partition tables. These two features, logical replication and partitions, these are the declarative partitions that we added in Postgres 10, arrived in Postgres at about the same time, but you couldn't use both of them. If you partitioned your tables, you couldn't replicate from them or to them, right? The new thing here in 13 is you can replicate from a partition table, and at this point, by default, every partition is replicated separately, which means that on the receiving side, you have to have partitions with the same names and exactly the same setup as you did on the primary side. Or you can set the flag publish via partition route, where everything will be replicated from this virtual partition route. And at that point, you can have a separate set of partitions on the receiving side, or just no partitions at all on the receiving side if you want. And as part of this, it also allows receiving replicated data into a partition table. So you can replicate from partition to partitions, or from non-partitioned to partitioned, or from partition to non-partition. Like, all the different combinations are supported. And this sort of unlocks one of the last, I think, remaining things where partitioning your tables could force you to stop using some other things. Along this, we also now have something called, or a parameter called logical decoding workmem, which sets the amount of memory we can use for logical decoding before it starts spilling to disk into temp files. And if it does, you get in pgstat replication, you get two new columns called spill count and spill bytes. That says, well, how much it has been used in this connection. Default is 64 kilobytes. I think the generality is if you have large transactions that are being logically replicated, you may need to increase this. But of course, then you have to balance it across the amount of memory that's being used, and across how many receivers do you have for your transactions and things like that. So it gives you another tunable around those and the associated metric points. Our walreceiver now uses a temporary replication slot by default. So that means if you have a replication standby that connects to a master, it will, when it connects, create a temporary slot, so that as long as it's connected, it will not fall so far behind that it will be unable to catch up. However, if it ever disconnects, this is a temporary replication slot. So if it disconnects, all bets are off. You should, in most cases, really be using a permanent replication slot if you're setting up important replication. But in the case that you don't, you will now at least get a temporary one used by default, because we can turn on the temporary ones without a lot of risk. Another thing around slots is there is now a new parameter called max val slot keep size. This tells you, so whenever you have a replication slot on your primary, and your standby server, whichever standby server is using the slot, disconnects and doesn't come back, or is not connected at the time, that will prevent Postgres from recycling the val back to the point where this standby disconnected. And this Postgres will just keep that around forever until you run out of disk space. And this Maxwell slot keep size puts a limit on that, saying, well, maybe I will only keep 50 gigabytes. And if the standby has fallen 50 gigabytes behind, then I'm just going to kill it. And what happens then, it basically just kills the replication slot, at which point, if the standby then connects, well, now the standby is dead, right? Now the standby doesn't work, but we didn't run our primary out of disk space. So again, this is a trade-off in between the running out of disk space on your primary versus keeping your standby nodes alive. But it gives you a way to put a ceiling on exactly how much memory is going to be eaten there. We now have the ability to online reconfigure, and this is one of the main reasons, I think, that recovery parameters in the previous version moved from recovery.conf into the main configuration file. The reason for that was to be able to change them on the fly without restarting Postgres, but then we didn't actually manage the important ones. Now, as with Postgres 13, you will be able to change primary coninfo and primary slot name without restarting Postgres. So that means you will be able to take your standby server and point into a different primary server without restarting it. So this is, for example, if you did a switchover or failover of your primary, so if you have 3 standbys, A, B, and C, and you moved your the primary role from A to B, you can now reconfigure C to talk to B instead of A without restarting it, and also changing the slot name without restarting it, which is, of course, really useful if you, for example, have queries running on your standbys, because restarting would kill all those queries, and now they can keep running, and we can just repoint your standby node to talk to a different server. You do this by editing the configuration file, or you can do alter system set, whichever way you change your global Postgres configuration will work, and you just do a reload instead of a restart, and it will just work. So, a few words on a couple of features around performance, because of course, everyone loves better performance. Right? Postgres 13 will have something we called incremental sort, which optimizes a multi-level sort. So the idea here is basically if you, so in the simplest form, assume you have a table with multiple columns and one of them is indexed. And then you query it and you say order by indexed column, comma, non-indexed column. In this case, Postgres will be able to utilize the fact that if it queries the index, the data is partially sorted. Because as the data comes out of the index, it's sorted by the first key, but it's not sorted by the second key. But it then knows, and it can split this into so-called buckets and sort each one of them individually. So it knows that, well, every value for one will come first. For one in the first column will come first. I can just sort those. And then when it's done with that, it can just throw that out as the result and move on to the next one, which means it can use a lot less memory to sort large amounts of data, even when only parts of it is indexed. The same will apply to other levels of, where lower levels of the query, if you will, is partially sorted, where you might have, a join running at a lower level, and then there's a group by at a higher level. Postgres will now know that the data coming out of the lower level is partially sorted, but not fully sorted, and be able to apply this optimization around that one as well. So in some cases, this might mean that if you have indexes that you've created just to be able to sort by them in a query, if there's partially overlapping, you might be able to get rid of them and maintain almost the same reading performance, while getting rid of an index loses a bunch of overhead. That's always good. Postgres hash aggregates can now spill to disk. This is actually one of the pain points of Postgres 12 and earlier, which is that when Postgres has decided to use a hash aggregate, this is used by group by, it's used by distinct and grouping sets, and it does so based on the estimate of how much memory it's going to take, and it compares that to workmem, and basically if it figures it cannot do it inside a workmem, it just doesn't do it and switch it to a different query plan. But the pain point is if it thinks it can do it within workmem, but then it turns out that it couldn't, then Postgres will just unboundedly allocate as much memory as it wants. And this is a pain point when you have a bad query estimate. You can end up allocating much, much more memory than you had configured, and then the killer will kill your server. Nobody likes that. Postgres 13 will both be able to intentionally plan a hash aggregate when there is not enough work mem, but in particular, if it thinks the hash aggregate is going to fit in memory, it starts running it, and it turns out that it didn't fit in memory, it will then switch and spill this hash aggregate in a controlled fashion to disk, similar to how we've been doing it for sorts and sort-based aggregates before. So it just makes hash aggregates safer in that case, which also means that we can now use hash aggregates in more cases than we could before, which is always nice, because in a lot of cases, hash aggregates are an excellent way to do aggregates. We now do WAL usage tracking, so you can now in your explain queries, if you say explain analyze, you can now say explain analyze comma WAL. It will give you, so in this case, you see the explain analyze comma WAL insert into n values 11. I'm just inserting a value. It'll say, oh, I ran an insert, and it says WAL records 1 bytes 59. So this insert generated a single record in the WAL, which was 59 bytes. Now, obviously, for a query this simple, that's not too interesting, but neither is the explain analyze that says this took 0.09 milliseconds. Of course, this becomes interesting when you're running larger queries. It'll then tell you how much they're actually generating. And this WAL usage tracking is also available in pgstat statements. So grouped by the statements that you're using, you can say, oh, the average of WAL generated by this statement is however many records and things. So this is one of the things that we've added to pgstat statements. The other thing is these planner statistics, which is the reason for the renaming of columns. In 12 and earlier, pgstat statements had the execution statistics, right? How many times have my query run? How long did it take? Things like that. Postgres 13 here adds a column saying plans, which says how many times has this query been planned? Total time, how much time is spent on it, minimum, maximum, and mean time on planning the queries. And then we have the records for WAL records, WAL FPI, and WAL bytes saying, okay, this query, so in this case, insert into n values $1, has generated 1 WAL record, 1 full page image, and 618 bytes. And of course, again, this becomes more interesting if you have some actual data in your system and actual queries. But it'll give you that information. So let's see, we have another question, which is what kind of provocative question? Oh, that's fun. What do you think about turning off fsync during large data migration? Is it completely a no, or maybe with sync and pgdump to devnull to be an option? So is turning off fsync during a large data migration a good or a bad idea? Well, what I usually say is, I mean, by default, you should obviously never, ever do it. But there are cases. If you want to turn it off, it has to be when you're doing a large data migration into a completely new and empty Postgres cluster, right? It's not okay if you're loading data into a table in an existing database. It is not okay if you're loading data into a new database in an existing cluster. You have to be willing that if anything at all goes wrong, you have to wipe the whole cluster and start over from initdb. Right? But if that's okay with you, if you're willing to do that, then yes, sure, run with fsync off. Now, my recommendation is run with fsync off. Then when you're done, you turn fsync on, and then you reboot the whole machine. Once you've rebooted the machine after that, then you know that every cache at every layer has been properly flushed. And when you've done that, you should be fine. But you don't consider the migration done until the machine has been rebooted. And if you say, well, rebooting takes too much time, then, well, clearly you didn't save enough time by doing this, right? If you only save that much time that a reboot makes a difference, then don't do it, right? But sometimes maybe this migration will save you, 24, 48, or 72 hours of loading time. At that point, you can certainly afford a reboot. So yeah, there are use cases for it, but it should absolutely never be the default path, because any step missed, and yes, you will have, and the scary thing about running with fsync off is you will not only have corruption, you will have silent corruption. You won't know that you have corruption until later. Running a pgdump to devnull is not enough. to verify this, because the corruption could be elsewhere. Could be in indexes that pgdump does not see and things like that. Checksums does not protect you against this because it could be right ordering problems and things like that. So it is a dangerous way of doing it, but it is also a way that can save you a lot of time. So one of the possibly biggest feature on the performance side is the deduplication in B-tree, which is if you have an index with many duplicates in the value, like many values across entire rows or partial rows, Postgres 13 will simply store this in a more efficient way. Will reduce the storage, which of course reduced storage means improved performance. And I think this can turn into one of those like hidden gems where it just works, it just makes everything faster and everyone's happy and you don't really have to do anything. Like you don't have to change anything in your application. If your application hits the sweet spot for the deduplication in B-tree, you will see significant performance increases in anything to do with these indexes because they're smaller. Of course, if it doesn't hit it, then it makes no difference whatsoever. Right? Then it doesn't help. So it helps for fairly specific use cases, but when you hit those use cases, it does indeed help quite a lot. So having been through, there's always more, right? This is the point where I usually point out that if there's any contributor in the room, so I guess if there's any contributor in this Teams meeting and I didn't mention your feature, I'm sorry, there simply is not time to list it all. There are hundreds and hundreds of smaller things, small fixes, small performance improvements, small sort of everything. No way to mention all of them. Let's see, we have another question there. Let's see. Are there any plans for implementing dynamic bloom filters like the one in Oracle? I don't know of anyone working actively on it. There are some, there is some bloom filter plugins for Postgres that's in contrib. I don't know enough about how the dynamic bloom filters in Oracle works to say what's the overlap, and I don't know anyone who's working on that in particular. Second question is, does B-tree dedup help with MVCC duplicates? Not directly. It does so indirectly, but the real win is when it's like actual duplicates. But it will indirectly help when you in some sorts of the other updates, but not as a general thing.
I have like another question because I'm doing a lot of Oracle to Postgres migration, and what I'm really struggling with, it's like when in Oracle you've got a partitioning key that is not a part of primary key, and do you know maybe about like any patches or something that will like allow us to do that in Postgres?
Yeah, I think the thing you were asking is basically the ability to have a primary key that spans multiple partitions without having the partition key as part of it, right? And
yeah,
I know that's one of that's probably the one really still like what do they call it, global primary keys or something like that. It's the one big feature still left in partitioning we don't have yet. I don't know if anyone's working on it actively right now. I have not seen a patch for it. I know it's on people's radar, but like that would be good to have.
Yeah, that would be great.
But I don't know of anybody working on it at this time.
Okay.
So at this point, it's my appeal to you, right? Please help. Download and test this beta version of Postgres 13. There are packages available in apt and RPMs and yums and all of that stuff. You can just download them and run them. If you have tests for your application, please run your application tests against Postgres 13. Unless you're desperate for one of these features, you should probably not upgrade your production to Postgres 13 yet. I'm running it in production, but it's not for mission critical systems. You probably shouldn't, but if you can have if you have tests, if you have continuous integration, things like that, if you can point that at a Postgres 13 and just let us know that we didn't break things, or if we did break things, it's even more important to let us know that now, because it will be a lot easier to fix that now before we have the actual release out. and it will help you in that once the release is out, well, you're already run your test against it. We're also interested in things like, in particular, if you have like performance tests for your application, run them against 13 and see if it goes faster, and again, if it goes slower. There was something reported just late last week, I think, where there was a non-trivial performance regression where 13 was actually slower than 12. And we want to know that before we make the release so we can get that fixed. In this case, I think the discussion, I think that one came out of pgstat statements, these planning time numbers for pgstat statements. So the discussion now is, should they actually remain on by default, or should we make them, they're already configurable. It's really what about the default, depending on things like that. And the way that we can get that data right is to know how Postgres 13 performs and how Postgres 13 works with your applications, because you're the ones who are running real-life applications on Postgres, right? To make sure that you get this tested, help us test it out. That's the easiest thing that you can do to really help with the Postgres development and make sure that once we get version 13 done, it'll be a high-quality release where, you know, pretty much everything works out of the box as it's supposed to do. So with that, that is all I had to say today. I'll be happy to continue taking a bunch of questions either through the chat or through you unmuting yourself to ask the questions. So thank you very much.
Thank you a lot, Magnus. Do you have any question, guys?
Well, the talk was great. I think it was very throughout on all the upcoming shining features. I can't think of any specific questions I might have. I might underline that I'm really looking forward to the append-only auto vacuum running, as that's something which is frequently coming up in my applications, where we have several large append-only tables. So I'm glad that this will show up.
Cool. Yeah. I think that's going to be. It's one of those that a lot of people today probably don't realize that they have a problem. Right there, because everybody thinks, well, it's an insert-only table. I don't need to vacuum. But it turns out, yes, there are use cases when you do need to vacuum insert-only tables as well.
There is a question in the chat about zheap in 13. Do you know anything?
Okay, I see it there. And the discussion on zheap in 13. It's not going to be in 13. It is not done yet. I believe people are still working on it. A number of the key developers of it changed their company affiliation. And therefore have sort of at least taken a break from zheap. It's, as far as I know, it's still being worked on, but it will not be done in time for 13.
So maybe I will ask one since there's no other questions, because I like quite frequently like talking to Oracle people, you know, and like the argument that they like, you know, bringing, it's like, okay, Oracle is much better because, of course, there's like a bunch of reasons. And one of them quite common is like when there is a page corruption in Oracle, then Arman has got this ability like to change only like, you know, single page, like the Oracle instance. Yeah, so it's quite common question. So it's, as far as I know, there is no so simple solution like in Postgres. So what would you say like here?
It is correct. There is no such simple solution in Postgres. I wish there was. I've actually talked to some people about it, and everybody tends to start with, that's impossible, and then you get it a while, and then you realize, yeah, well, maybe that could be done, maybe, kind of, but it's pretty hard. I think the closest you can get to it today is basically, I mean, one problem is you want to be able to restore that page without rolling back the whole database, right? And that's the difficulty, and it could certainly generate a bunch of other corruption instead. But it should be doable by basically going back to the backup and then going through the transaction logs across this one page only. But it's pretty complicated. What you can do, like if there are two reasons to use this, right? One of them is that your restore becomes very fast if it's just one block. That you can almost work around by doing a full database restore, for example, using the Delta restore feature of PG backrest, where it will not restore just the one page, but it will restore just that one file, basically. But that'll still be on a large database. That's still a lot faster. However, it does still bring in the whole, yes, you do have to roll back the whole database to whatever point that is. So you can't just keep making changes in other tables while you restore this, for example. So yeah, that's one I fully agree that that's a brilliant feature, and I would really love to have it. And I don't know of anybody working on it.
Do you think, for instance, ZFS could help with this problem?
No.
No. Okay.
That's all very simple. ZFS will not help with this problem. Because you need the code that handles this restore needs to know exactly what goes on this disk page, right? Because you want to restore the disk page, but you want to restore it to what it should look like now. So you can't just go back and restore it to the last backup. Mm-hmm. ZFS might be, through some magic, be able to restore this page to the way that it looked when you took a snapshot last night, but that doesn't really help you, because any changes since can, of course, could make it all corrupt. So you need something that is capable of following through the Postgres transaction log and incrementally figure out what this page looked like.
Yeah, I've heard that. The only advantage in ZFS, it's you will get this information that something is wrong much faster. So that's the only.
You could, but if you're using checksums in Postgres, which you should, you will get the same. You will get it just as fast.
Okay.
So ZFS does block level checksumming in the file system. Postgres with checksums enabled does that on any file system. And it will just if you're taking your base backups with PG base backup or with backrest, or I believe with barman, at least it will validate all the Postgres checksums on every backup as well, which is otherwise also a functionality that you would get out of ZFS. So ZFS is certainly a good file system, but it does not solve this particular problem.
A question regarding checksums. Does Postgres has something like a background SCRAM when without accessing page block without any other reason, it can just go through blocks and calculate checksum and see if something has been silently corrupted in the background?
So does Postgres check them in the background? The answer is, with current versions of Postgres, when you run a backup, right? When you do a PG base backup or a backrest backup or so, it will validate the checksums in the background. There is a tool that you can run that will validate them offline. You can actually run it online because it's a command line tool, but it can then give you false negatives if things were happening at the same time. And there is actually a patch in the queue for Postgres 14 to have the ability to do online checksum validation without backups. But right now, your best bet for that is you could just run a PG base backup to DevNull, for example, will perform a complete checksum validation across the whole database.
And about this renaming stuff, it's I've always been struggling with pgstat, pgwriter. I've got a lot of questions because people just don't understand what's in there because of the really bad naming, in my opinion.
Are you bringing that up because you think that I came up with that name?
No, but you are the person to blame, so
Really, I think in this case it may actually be my fault.
But it's really, this max written clean and so on. That's really not easy, to understand. So.
Yeah, it's not. Number one is that the pgstat BG writer is kind of a bad name now because it contains stats of a bunch of things that are not the BG writer. And then
exactly.
Yeah, I think in particular the max written clean is not exactly self-explaining. I fully agree with that.
Yeah, well, like any other, like much more column there. So there is no plan to change that, right?
I think the way to fix that is to figure out some other statistics that you want to go in there that will make it inconsistent, and then we can fix them all.
Okay.
Because I don't think, I mean, in general, renaming it just to make it more clear will just break so many monitoring software for not like a proper reason. But if there is another reason to already tweak something in this view that will make it incompatible, then you can throw in a bunch of extra incompatibles at the same time.
Yeah, that's totally like get that.
So we have the question: is there a migration from older versions to Postgres 13? And I see Alicia answered PG upgrade. I think the other point to mention is you can upgrade from any supported Postgres version directly to Postgres 13. Right? You don't have to go via another version. If you have Postgres 9.6 today or 9.5, you can just upgrade directly to 13. You don't need to go buy 11 or 10 or something on the way. Just go directly. And yes, PG upgrade is the fastest and most efficient way to do these upgrades today.
Okay, since there is no other questions, I think like we can finish here. So thank you a lot. Yeah,
one more thing. I don't know if I can make an announcement regarding my activity, because we are actually doing some more basic webinar in 2 days with Cybertech, me and Karel Moppel. And I don't know if Alicia is going to allow me to just paste the link.
Yes,
okay.
Please go ahead.
Okay, and then I will add a comment on the meetup site. So this will be rather basic regarding things like Oracle migration, like Karel will be talking about big data, about analytics, and in Postgres deployments in enterprise and enterprise-oriented features of Postgres. 3 30-minute talks. So on the website with registration, you can just get the schedule and join anytime you want. Thank you very much.
Okay, so thank you both for that, and yeah, thank you a lot to Magnus for doing that. As you see, like a lot of people like were interested. So I really hope that you will come to Warsaw, like for the normal physical meetup. So since you are like founding father of it, so you need to.
Thank you so much. I definitely will come when this whole mess is under some more control. Let's put it like that.
Yeah, sure. Okay, so thank you a lot. I'm stopping the